Hello everybody, and welcome to my 7th video on this is a practical demonstration of the binary implemented ternary logic circuits that I presented in a few videos. So I've built these functions and I'm going to demonstrate what the oscilloscope waveforms look like. So here we have the signal generator. This is a 5 megabit signal generator. There's a 5 megahertz crystal oscillator there, TTL, and some binary counters generating the sequence 012, 012, 012, 000, 111, 222. So on the oscilloscope, this is a ternary logic 0, this is a ternary logic 1, this is a ternary logic 2. This is the ternary logic 0, this is the ternary logic 1, this is the ternary logic 2. So this is a signal generator. As you can see, it's got supply decoupling with a 10 microfarad, 10 nanofarad and a 10 picofarad capacitor close to the supply pins of each chip, 5 volt voltage regulator, and I'm feeding it from a 9 volt DC supply. So do have a clock as well. This is a TTL, this is the oscillator, the 5 megahertz oscillator coming out of the chip, coming out of the SIGGEN. So I'm going to be demonstrating a few ternary circuits. I'll start with the successor function. I'll just turn the power supply off. And I'll connect the output. Connect the output to there, the input, and connect the earth. Right, we should get successor function. What have we got? Scoping. Oh, we're not scoping that. There we go. Right. So we've got the input, which is the bottom waveform. This is the ternary generator 012, 012, 012. And in response, we get a 201. Is that? That's right. Is that right? Oh, it's a top waveform. That's right. That's right. So, in response to 012, 012, 012, we get 120, 120, 120. So that's what the output should look like. This is the input and that's the output. So that's the successor function. Yeah, I'll show you the predecessor function. So I'll just wire this up. Connect the inputs. Wire the output up. Okay. Should be in business. Right, there we go. So in response to 0, 1, 2, 0, 1, 2, 0, 1, 2, we get 2, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1. So that's the output from the predecessor function. There's a little bit of a static hazard there, but it's not to worry because the output is still within the range. I'm using ×10 probes for this. I've got each volt per division set at 0.2 volts per division, which when in a ×10 probe is 2 volts per division. So that's approximately 5 volts. That's approximately 2.5 volts, and that's 0 volts. Same with that one. Okay. Now then. I'm going to show you the minimum of function. Right, connect the ground up, input A, input B. And connect the output there, and we'll scope one of the inputs. Right, see what we get there. Right, this is input B, 0001112222, and this is the output of the minimum of function. See, it is a 0 when B is 0, A is a 0 there and a 0 there, 2 there, and 1's there. So that's what the output of the minimum of function looks like. A little bit of a static hazard there or something going on there, but apart from that, it's a quite clean signal. Right. Next we have the maximum function, maximal function. Connect it up. Connect the output up. And scope the input B. Let's have a look if we can get. There we go. So this is B012, and this is a maximal function. It goes 012 112222. So when B is a 2, it's a 2, and A is a 2 there and there, and 1's everywhere else, and a 0 there. So that's the maximal function. Next we have the difference of function. Right, we'll wire this up. Scope input B and scope the output. Alright, this is the difference of function. Here I have input B again, here it's 0, 1, 0, 0, 0, 1, 1, 1, 2, 2, 2. And we have 0, 1, 2, 1, 0, 1, 2, 1, 0. Little bit of a static hazard there and there. And the output is a 0 when both A and B are equal. So 0, 0, 1, 1 and 2, 2. So that's the difference of function. Next we have the modulo 2 edition. That's not the modulo 2 edition. This is the modulo 2 edition, modulo 3 edition circuits function. Sorry, we'll wire this in. Scope input B, and so here we have 0, 0, 0, 1, 1, 1, 2, 2, 2 for input B, and we have 0, 1, 2, 1, 2, 0, 2, 0, 1. So that's basically 0, 1, 2 when B is a 0, 1, 2, 0 when B is a 1, and 2, 0, 1 when B is a 2. So looks like a nice clean waveform. A little bit of a static hazard there, nothing to worry about. Next we have the modulo 3 product function. Just wire it in. Right. Connect the earth. The oscilloscope probe, and oops, connects it up. Right, here we have the modulo 3 product function 0, 0, 0, 1, 1, 1, 2, 2, 2 for B. Anytime you get a 0 on any of the inputs, the output's a 0. So 0, 1, 2, 0, 2, 1. And that's the product function, because 2 times 2 is a logic 1, modulo 3. Okay, a little bit. I'm not sure if that's the oscilloscope or whether that's the actual waveform, but it seems to be pretty clean and clear. Alright. Notice on all these chips I'm using the decoupling capacitors close to the supply pins. That just helps the waveform, because you may get parasitic oscillations on your square wave, on your ternary waveform. So just something to watch out for. Right. Next I'm going to show you the D flip-flop. So what I'm going to do is I'm going to wire it with a successor function from the output to the input of the D input. So I'm going to use, that's the clock, That's the D, that's the clock input. This is the successor function, which I'm going to wire in as well. Right, now then. So I'm going to wire the output to the input, and the output of that to the input of the D flip-flop. I've connected the grounds together and I'm going to scope the output. So connect the ground. Right, see what we get. There we go. So this is the input here. We're scoping. Yep, that's the clock signal, the input to the clock, and this is the output from the flip-flop. There we go. So in response to a negative edge on the clock, the flip-flop changes states from a 0 to a 1 to a 2 and repeats. So that's a D flip-flop with a successor function wired from output to input. A little bit of static hazard here, I don't know what that is, that may be the scope or it may be the circuit. You've got to be careful of supply decoupling. So anyway, that concludes the presentation. I hope you enjoyed it. Thanks for watching. Bye.